All right, I love Ohm's law, and you should love Ohm's law too. If you almost everything we do is going to be based on Ohm's law. We need to be able to do Ohm's law with our spinal column. Now, strictly speaking, Ohm's law defines resistance. So, for example, if I've got, say, 12 volts of pressure or potential here, right? And I've got a current here flowing of 2 amps, right? The resistance in there is 12 volts divided by 2 amps, right? Is 6 volts per amp is 6 ohms, okay? So an ohm is a volt per amp, right? It's, yeah, there it is, right? Now, obviously, the more volts you need to get 1 amp to flow, the harder it is to get through there. So resistance is basically exactly what it says. It's the resistance to electrical current. So you could think of it as, if it's a pipe, it could be a section of pipe filled with gravel, right? And really high resistor could be like sand or something like that, right? It's a resistance to the flow. The more resistance, the less current you have, okay? I tend to think of it this way in terms of current. So current is voltage divided by resistance, which of course is exactly the same thing, right? You can also write it V as IR, right? So R is V over I is V over R, and V is IR. Whoops, I can't talk, right? So all these things, we should be very, very good at this, right? Anyway, so, and I've got a demonstration of this. It's not a great demonstration, but basically I've got a power supply, and when I increase the voltage, the light will light up more, right? And when I increase the resistance, the light gets dimmer. I put a little light bulb in here, like that, right? Anyway, let's do the example problem that you've got there. I would do very many of these practice problems. Oh, this is just a, by the way, right? This is the color code that they've got on resistors because they're small, so they put the resistance in there as a color code. So for example, this digit, the first digit is 2, right? The next digit is green, so that's 5. And then the next one is, what is that, yellow? I feel like that's yellow, 4. So it's got 4 zeros, 1, 2, 3, 4. So that is a quarter meg resistor right there, okay? 250,000 ohm resistor. But anyway, yeah, anyway. And then, by the way, the last one is the tolerance. So gold are the more expensive ones. Silver is 10%. It's within 10% of what it says. Yeah, there we go. There's a way to remember that, but it's not. I'm not going to put it in the video. All right, so let's look at this thing, right? What is the resistance in the circuit above? Okay, so the resistance is V over I. And there's 12 volts, right? Over that, right? And then there's 120 milliamps, so 120 times 10 to the minus third amps, right? Or 0.12 amps, right? Well, 12 divided by 0.12, you guessed it, that is 100 ohms, right? And I feel like that is, what is it, brown, black, or something like that. I don't know. Brown is, let's figure that out. Brown is 1, black is 0, and then one more 0 is 100. Only that thing will go away. All right, so let's do the second problem here. If there's a 220 ohm resistor in the circuit above, and the current is no longer 120 amps, right? Okay, let's say that that's 220 ohms, right? What is the current? Well, I is going to be V over R, so it's going to be 12 divided by 220. 12 divided by 220 is 0.5454, repeating, right? And that's amps. Oh, it's 0.0, sorry, 0.05454454, right? Or you could say about 55 milliamps. Just move the decimal point 1, 2, 3. Yeah? All right. Do the whiteboard problems, do them all. You need to be very good at Ohm's law. And you can't be thinking about it. You just have to be able to react to Ohm's law, okay?